Hello, and welcome to the Git Intermediate tutorial. We're going to be talking about branching and merging here. This is where Git really starts to shine as something that's very helpful for managing the version history of projects. So the first thing we're going to think about is the duality of a commit. So what do I mean by that? I think an example will be helpful. So let's just initialize a repository and give it some commits with something to work with. So I'm just going to go into my SSPI folder. I will go into, let's make a new folder. Let's call it, we can call it just test for now, cd test. And then we'll git init. So that creates a new repo. We'll rename the master branch main. Oh, well, I called it main. Let's see if we can do that. So if we check our git status, yes, we're on main. Good. So no commits yet. And so let's make some commits. So first I'll echo something into a new file called file1.txt. So I'm just adding some text to a new file. That is the notation in bash to do that. I'm using the echo command, and then I'm using this little funny triangle operator to create a new file and then add the contents of echo, which remember is like print, into file1. So let's just do that. And let's just check our git status to see how that works. So yeah, I have to add this. So I'll git add, and since I know there's only one thing, I can just say dot. And remember, git add dot will add everything in your working tree. So everything in your working tree into the staging area. So now I will check my status and you'll be able to see I've got a file. Cool. So I'm just going to add a commit, and let's see, what did I say? Just for sake of continuity here, let's call this initial commit. That's a bad commit message, but you know, whatever. For now, let's just do that. So git status. So now if I check my git log, you can see that I've got one commit in there. I've got one commit with this hash, and it was created by me just now. Cool. So now let's move to the next set of features, right? So I am sitting here on branch main, and I'm going to add another file. Let's do file2.txt. I'm going to echo into, and I have to decide something to echo. Anybody got let's see. Oop, so blew that one. Let's do let us go then, you and I. Some proof rock. Cool. So now if I ls, you can see I've got two files, right? I've got file 1 and file 2, and if I just cat everything, then you can see this is from file 1 and this is from file 2. Nice. So there we are. And cat is a command to concatenate the contents of files. So I just printed out everything here because I concatenated the contents of those two files. So cool, just little things. And let me git commit. Sometimes if you know you just have a little thing to do, you can use this -am. So this is saying commit, add everything first, then put a message, added feature A. And the problem is that it's an untracked file. So this -am thing only works when it's not a new file that you haven't set up tracking on yet, and it's just a file. It only works when, you're not dealing with an untracked file, which is slightly different than a file in your working tree, right? So maybe one way you could revise this is to say there are untracked files, which are not even in the working tree, like they just haven't even been known to Git yet. So yeah. There's always a little bit of nuance that we're eliding to make it a little bit easier to understand. But so if I git add dot, then I check the git status. I can see that I have staged the file, so I've moved it into the staging area. And now it's going to be a git commit. And let's just, for the sake of it, go into Vim to do it. And if you are in here and you are stuck and you're like, I'm trying to hit escape and nothing's working, first, you're going to write your message by pressing I. Then you say, well, what do you say? You say added feature A. And then you hit escape to exit insert mode and go back into normal mode. And then you hit :WQ and hit enter to leave Vim. A little bit complicated, but I promise there are good reasons why it's structured that way. Okay, so now if we check our git status, you can see we are on branch main with nothing to commit. Let's just do one more. I guess we have 2 more to do. So let's just blaze through these really quickly. So we will echo any new poetry to do, to be or not to be. Well, I guess we need to hold that is the question. Whether it is nobler in the mind to suffer. All right, let's do file3.txt and git add dot git commit, and we did fixed. I guess I didn't really fix bug. B, cool. And then let's just do one more to get ourselves set up. Again, checking the git log, you can see we're approaching the commit history we had looked at before, because you can see here we've got 3 commits. Yeah. So let's just do last one, and this one says refactored code. So maybe I will refactor by switching the contents of file 1 and file 2. So I'm just going to open both of those files. Let's see. You can use this globbing notation. So the one with 2 and the one with 3. I'll switch file 2 and file 3. And these are side by side now. I will just move these around. Cool. So suppose I leave all those. Now we can commit those changes. So git add dot. So I'm adding both of those files. So now we have 2 files which have both been modified, and they've moved out of the working tree and into the staging area. And then I'm going to go forward with commit, and I will say refactored code, just because that was what I wrote in the example. So now we have the example set up. So git status, git log. Sure, so here we are. We have this exact commit history. And one thing you can do is actually see the changes. So remember git log, what is it, stat? Oh, not stats, stat. Cool. So now each of these shows exactly what happened. For file 1, we changed 1 line, so that's 1 insertion. For file 2, we added a new file with 1 line. And then file 3, we added a new file with 1 line. And then you can see here, we deleted 1 and added 1 because that was the switch we made, right? So when I talk about the duality of commits, what do I mean by that? Well, if I look at, let's go up here. So if I look at this commit, right, there are 2 ways of thinking about it. This commit is the product of everything that came before it, in some sense, right? So it represents the entire history of the project up until this point, right? So I'm currently sitting here, and yeah, this is the whole history. And if I look at, say, the track files, right, if I ls, everything is here. So I'm not just having file 2 and file 3. It's not just the set of changes. It is, in fact, the entire state of the project up into here. But there's another way of thinking of commit, which is just that set of changes. And you can see that in this log here. So this commit corresponds to just this one set of changes, but it corresponds to the product state that happens when this is the last set of changes you apply to the previous commit history, right? So that's the duality. There are 2 ways of thinking about it. It's just a little set of changes, and it's the whole project history. So that is the really clever thing underlying all of Git, right? It's this duality here. And yeah, how do we go back in time? Well, we git checkout, and then we use the hash. So I want to go back 1 commit to fixed bug B, and I'm looking at that here. So you may not be able to do this in your terminal, but yeah, I can just highlight this here and paste it in. So I want to go back to here. I could git checkout there, but let's just git reset to jump back to where I was going. Oh, no, well, let's see. Git checkout. I'm going to do something I haven't taught you how to do yet, which is use the branch. So I've switched back to main. So now I'm back here. But yeah, just to really hammer home how this looks, we can go back in time by checking out a commit, and we only need the first couple things, the first couple letters to identify it. So A79, let's say, that will uniquely identify this commit. So it gives us this message, right, that you've switched to here. You are now in a detached head state. You can look around and make experimental changes and discard them without any problems. But if you want to create a new branch, you can do that, and we'll talk about that in a second. But yeah, we're in detached head state, whatever that means. And We'll think about that quite in detail in just a second. But what does this mean practically? Well, if I look at my git log, here's what you can see. That last commit is no longer visible in the log. So the project state exists only as, let's do with the stat, the set of changes, starting with file 1, file 2, and file 3 before we made that switch in commit 4 when we refactored code. And in fact, if I wanted to go back to 4, there's no obvious way to reattach my head to that front commit state. So let's just look at the diagram here. I was here, I checked out the previous commit, so now I'm at commit 3, this fixed bug B1, and now I don't know necessarily how to get back, right? So, yeah, I've moved my head pointer, we'll come back to this one in a second, but I don't know how to get back to here from here, unless I can remember the commit hash. So if I scroll up in my terminal, I can see that there is a commit hash here. So if I were to scroll all the way up and just remember that this is here, then I should, if I just git check out this thing, I can go back to here, right? So git status. My head is still detached actually, because I'm not pointing at a branch. Again, we will think more about what that means in a second, but now if I check my git log, I'm back in the right state, although my head is detached. So that is a little thing to think about. So what on earth am I talking about with this head pointer? Well, the head pointer is just the you are here. Where am I at right now? Which commit am I actually looking at, right? So which state of the project history being the line or set of branches of commits that go all the way back, just the project history, starting from the initial set of changes, the first things you put into all the files, tracking how did all those files change over time up to the current state. So when you move your head, you move the project state, right? If I cat out everything in this folder, you can see that to be or not to be, and let us go then you and I, they have been switched because I'm sitting at commit 4, so git log. I have 4 commits here, and I've refactored the code, but when I git checkout 1cc6, then you can see in the git log, this is how it looks, and what does that mean? Well, actually the state of these files is different, right? If I cat everything, you can see the order is reversed, right? So I have moved back in history because my head is now looking at a previous branch. Cool. So, yeah, this is a little bit of a motivating problem, right? If I were to say, clear the contents of my terminal so that I forgot what that commit was before here, then I believe the technical term for where I'm at is SOL, right? I don't know how to get back, and I've lost, in some sense, the project history. So that can't be how it is. How do we fix that problem? Well, here's how we fix it. We use branch pointers. And so this is where Git gets a little bit more complicated. We have to think about this concept of branch pointers. So what is a branch? It is just a pointer to a commit. So just a moment ago, we had head, which is a pointer to a commit. Now we're adding a new set of pointers, and these are special pointers that we call branches. And what do? Well, they just point to commits. I mean, that's why they're called commit pointers. But head, when it is attached as opposed to detached, is pointing at a particular branch instead of pointing to a commit directly. So in our previous model, you can think of this as the less sophisticated model that's a partial lie to help you sort of understand how we move forward. This is like the Bohr model of the atom, right? Like, here, I just had a head. I didn't even think about branches. I just want you to get used to the concept of having a pointer to a branch with the head. And this is kind of true, right? Like you can jump around like this. But in reality, almost all of the time, we're actually going to be looking at a branch pointer, which is itself pointing to a commit. Now, why is this important? Well, your head remains attached to this branch. So that's cool. Now we can still jump back. So let me just git checkout main, just so we're in the correct place. So if I check my git status, I'm on branch main. This is what it means to be on a branch. Your head is pointing to a branch name called main. And if we look at this and I check my log, then yeah, I've got all 4 commits and main is pointing down at that last commit. Nice. So Now, let's suppose I check out the previous one. So we're going to jump back to that third branch again, looking at it like this. Right, so I'm checking out that third commit, fixed bug B, which is going to be 1cc6 for me. Now, I'm in detached head state again. Now, why am I back in detached head? Well, I have detached head from the main branch, and it's now looking directly at a commit. Whenever you're looking directly at a commit, your head is detached. You are not looking directly at a branch. So main remains up here, and this is how I jump back. I say git checkout main, which is, pointing here. So instead of forgetting this commit hash when I clear my terminal or something like that, main is keeping an eye out and saying, I stay here no matter where you go, so that I can jump back straight away and my head is no longer in detached head state. Now, I guess I should show you. So git status, if I check it when I've jumped back, so I am sitting in this state here, my head is detached and I'm at this commit, right? So it doesn't, yeah, my head is detached, I'm sitting at that commit. Great. So yeah, let's jump back with git, another word that you can sort of use somewhat synonymously with checkout, but not really. This is the modern version. I learned back when checkout was still the accepted version, but switch also works. So if I git switch main, that also works, and switch is less to type than checkout, but if you've typed checkout a lot of times, you're used to it, and so whatever. But yeah, when I git checkout main or git switch main, I jump back straight to commit 4. So yeah, just playing through this, that's all I'm showing you. Nice. So that's the basic idea of a branch. Now, even with this, it's not super powerful, right? We've only had a linear history. They're just different points to jump back to and jump forward to in time. And you might say, Tristan, Google Docs does that. I can go into my version history. I get time-stamped, save points throughout time, and I don't even have to do them manually. So what's the big deal with Git? And that's true. But what we can do with commit histories is we can actually branch off of them. So here's what we're gonna do. I am sitting on main, right? Git status, looking here, and I'm going to create a new branch. So I'm going to say git branch feature C. Let's call it feature-C. Now, what happened here? If I check git branch, this is a way to just list your branches and see which one you're on. So I'm sitting on main still, nothing so special. And what does it mean to be sitting on main again? My head is pointing to the main pointer, which is pointing to this commit. And where is feature C pointing? It is pointing to the same commit I'm on. When you say git branch feature C, it just looks at, well, what commit am I at right now? And I create a new pointer to that commit. So again, nothing super special here is happening. And then as I branch off, well, first thing I'm going to need to do is actually switch onto the branch. Now, why is that? Well, head is where all of my, when I run git add, git commit, I am going to find where that head is pointing to add commits to that branch. And so we'll see what that means precisely in just a moment. But yeah, I've got a git checkout feature C, which is going to, again, not do anything so special. If I check this git branch, you'll see I'm now on feature C, no longer on main. But if I look at my git log, right, it's just the same old commit history. And you can see in here that, let's see, yeah, this area here is telling me, yes, main is pointing to this commit and feature C is pointing to this commit, but head is now pointing to feature C instead of main. If I were to git switch to main, again, git switch, git checkout, similar thing, just different. I don't know the technical points at which they're different, but checkout does more things. Switch is a bit simpler from what I understand. But for the most part, you're just using switch to switch branches. So I've switched to main. If I check my git log, you can see, what does it mean that I've switched to main? Well, in here, now I'm pointing at main instead of feature C, but both main and feature C point to the same commit. So nothing practically has changed for me in my commit history, but yeah, it's just a little bit of a, examples to understand what exactly is going on under the hood here. So if I check my git status, it will tell me what branch I'm on as well. So just saying on branch, feature C, nothing to commit, working tree clean. Cool. So now I am sitting at the state pictured here. Head is pointing to feature C, main stays here. Now, what's going to happen is I'm going to add some new information. So I will echo some new information and I'll use this little /n. That means new line, some more new information. Now, I have to add this little -e flag here because I've used that new line break character, and that Echo needs me to tell it that I'm going to use things like new lines. So yeah, that's all that -e is doing. Now this little double dash notation, or this double right angle bracket, is saying append the contents of the standard input to, and standard input is what I'm providing here with this echo, append those contents to file3.txt, and append means go to the bottom of the file and add them at the end, right? So just before I do that, oh darn, am I gonna have to type that again? I can copy it. Anyway, so let's just look at what file3 looks like. So again, using this globbing notation, I'm just gonna grab file3, and it just says, let's go then, you and I. Like this, when the sun is set out against the sky, right? Cool. So then I can jump over here. Oh, I can grab this line, and then I can copy and paste it into my terminal. If your terminal doesn't support copying and pasting, that's one of those features that's just like extra nice. So if I cat3 again, cool. So you can see that some new information and some more new information have been appended at the bottom of that file. So we've done our job correctly. We can git add just everything, since that's the only change, right? We check our git status. You can see we've moved it from the working tree to the staging area, again, keeping this mental model in our heads. And then we are going to commit -m added new info. Cool. So we've got that in, and yeah, so we've added a new commit. Now, what has happened? Well, let's check our git log to see a representation here, and we'll look at this representation here. So main and feature C have, well, maybe I wouldn't say they've diverged per se, although in some sense of this word they have. We'll see in a minute why I might not use that word exactly. But I have advanced feature C ahead, and yes. So, this is the one. Cool. Sorry, I jumped ahead. So, feature C now points to commit number 5, which has this commit message added new info, and we can see that here in the git log. And we have this main branch, which is still back here. It's still pointing to this old commit. So if I were to git switch main and check my log, you could see I haven't changed anything. According to the main branch, nothing new has happened. But we know that there's this other branch out here called feature C. And again, you could use checkout instead of switch here. And this switched. So now I'm here, and if I check my git log, then you can see that added new info is there. So these two histories are now rather independent. We can say everything on feature C, I don't have to worry about doing anything bad to main, because main just has its own thing hanging out down here. And yeah, any changes I make in this new commit on feature C are not going to affect anything negatively here. So yeah, if I were to check out main, just to totally spell this out, so on here, you remember we had this looking at the contents of file 3, and again, just spelling out what that globbing is doing. Basically, I didn't want to type file 3, so if I type cat star, this says anything that match a file that begins with anything, goes up until 3, and then ends with anything. And because I know the only thing that has a 3 in it here is file 3, then I can use this cat star 3 star to match only file 3. But if I had said cat star.txt, well, 3 files, file 1, file 2, and file 3, end with txt, so you can see they all get concatenated together in order, file 1, file 2, file 3. Cool. So yeah, just trying to show how this all looks, but cat star 3 star just has this one, but if we were to git switch, or I'll use checkout this time, just to show that they are the same, git checkout main, then we were to run that same command, and arrow up in the terminal is useful. You can just grab old commands, so it can save you a bunch of typing. Then you can see those changes are not there. So within individual files, we don't have to do anything special to track changes. It's all handled by this commit structure and branching. Great. So yeah, how do diverging branches work? So before I said, maybe I wouldn't call this a divergence per se. We can just move ahead. The commit history is still linear despite it jumping up here, right? It's just a line of commits. But what happens when we diverge? So imagine I'm sitting here. I'm on, I check my branch. I'm on main. Now I want to add new stuff. So I say mkdir feature d, and that is the command to create a new directory. And then I will just go over here and echo. I'll copy this little echo command into my terminal. So now if we see git status, well, I have this untracked file feature D, and don't worry about that being just the directory. It will track the change there too. Git actually doesn't really know about directories. It just has file paths that end in something. So if I git add, I could use this star D, right? Now this is saying, look at everything that has a D in it. And if I were to git status, you'll see that it has figured out that I mean feature D. So I've added that from my untracked files to this file here. And if we were to say git diff cached, this is the diff command. It will show you the difference between what's cached in your staging area and where you were before. You can see that there's this new file here, and it has this stuff, brand new information, really cool stuff, right? So I've just created that file down there. Now it is staged for commit, right? We are staged, we want to commit it. So how do we do that? We just say git commit -m, and then what did I say the message was gonna be? I can say added feature D. So we've made a new commit. Git status looks like this. Nice. So on here, nothing to commit. Now, if we look at our git log, what does the history look like? Well, there are 5 commits in this commit history. Now, that's interesting, right? Because we made that previous commit to feature C, but we can't even see feature C along this path of history, right? Totally independent. But if we git switch to feature C, then look at that git log. You can see we can't find main along this path of history. Our histories are divergent, and we have 5 commits in this history, and they are just, it's a different history than the set of commits in main. So yeah, we've switched over to here. I won't go through that here, but when we have divergent branches, why is this great? Well, we can actually merge those branches back together at the end of the day. So yeah, there's a special case called a fast forward merge. So let's say, let me show you how this works. So if I git check out this 4th commit, right, just to get something. So I'm here. Now I'm going to create a new branch. So yeah, just to spell out where I'm at. I want to make my history look more like this, a linear commit history. But I've already moved main ahead. But what I can do is check out this branch here, or not this branch, this commit. I can move my head to be pointing down at this 4th commit, which is where I'm at right now. If I check my git log, right, you can see there are only 4 commits. I'm standing on refactored code. Then I will say git branch, let's call it new branch for FF, and FF I will explain in a second. So if I git status, my head is detached, and I'm going to git check out new branch for FF. And if I check that, I'm on the new branch. So all I've done here is I was sitting at commit 4, and I called git branch and then checked out the new branch to create a new branch pointing here. So my head is no longer detached. It's attached to this new branch, which if we look in the full divergent history here, I've just added a new pointer called new branch FF, and my head is currently looking at it. So that's all that sequence of steps was right there. Sorry, I don't have a diagram for this one. It might be helpful to actually see here. But if I do git status here, and then I run this command git merge, then I'm going to do what's called a fast forward. Now, why is this? You can imagine just substituting new branch for FF with this feature C. We don't even have to worry about main branching off down this way right now. But if I run git merge feature C, I will do what's called a fast forward. Now, why was it a fast forward? Well, the difference between this branch, or this commit here, and this commit here is just, one commit. And this branch is just pointing at that commit. This branch is just pointing at that commit. So the difference between these two branches is just adding this one commit to the end of the branches. So instead of having to, say, create a new thing with an identical commit added to it, right? If we want it to merge it forward, we just instead move this pointer ahead. And again, remember, this is not main. This is this fast forward of new branch for FF. So yeah, that's what a fast forward is. And now if I check my git log and I switch to feature C, I don't want to switch to it. I want to just switch feature C. Then yeah, you can see that the logs are identical and that these two branches are pointing to the same place, right? So if I were to take a look at my git log with a graph in it, let's see, one line. We won't look at the graph quite yet. That'll be more helpful in a moment. So can I do dash all? Oh, yes. So here's my status. And you can see it looks just like this picture turned on its side. So previously, maybe I should execute this one more time just to see it. So I'm going to do git checkout this new branch, 709, or this old one, 709 AEA. Cool. So I'm in my detached head state. If I git log, you can see my head is here. Log, one line, all, graph. These are the options I want. So head is down here before these two things have diverged. Now, when I git checkout dash B is to create, let me just go through the full commands. Git branch new. So I'll just call it new for now. And I check this git log. You can see I've got a new branch here, but my head is not yet pointing at it, right? I'm still in detached head state, but when I go through and I git checkout new, now you can see I've switched to the branch. So if I check my git status, my head is no longer detached. I'm on branch new. And what does that mean? Well, now my head is sitting down here and I'm on this branch and new is pointing at this commit here. Now, when I run git merge, how does git merge work? Well, when you're merging something, you are going to pull in the changes from that branch that you specify. So you're sitting on a branch and you say, go look out at this other branch, and then pull in the changes from that branch to my current branch. Now, when you can just step your branch ahead and there's no divergence in the histories, then the merge will be a fast forward. Again, not the clearest, but we'll work with it a little bit more. So let's merge in main this time. So what's going to happen? Well, I'm going to git merge main. This is going to be a fast forward. And where do you think, just think in your head for a minute, where head is and where is new now after this fast forward? So if I run this log command, you can see that head has advanced to where main was because I merged in the changes from main, which really just means moving my branch pointer ahead, since there's a very clear way to do it. There's no ambiguity there. It's just like if you want to merge in main, well, all it means to merge in main is to merge in the changes from commit number 5, which is the same thing as just going to commit number 5, right? I think that's the best way to say it. Cool. So that is how branching and merging works when it's a fast forward. But you can see here, we've got a little bit more of a problem with main and feature C, because there are two different ways you could go on the tree. And we need a way to reconcile, what would it look like to merge, 6 and 5 into a final commit, number 7, that kind of reconciles these two divergent paths. And that's what the three-way merge does. And the way it works is it identifies a base commit, which, again, remember, a commit is both a set of changes and the project history up to that point. So the base commit represents the kind of starting point where things have branched off. You can think of like the common ancestor of two species in evolution, right? Like the base commit is the common ancestor. And then we have these two bundles of changes specified by commits. Now, we could have many commits along different lines. Sometimes commit histories are going to be very divergent. There might be many, many layers of commits, and we need some way of, when we're bringing them together, to like reconcile how they all come together. Now, you can imagine that since, let's just run this merge, and then we'll talk about it. So I'm going to git checkout main. So I'm going to be sitting on main, right? If I check this log command, you can actually see here I am on main, head is pointing at main, and main is at add feature D. And I'm saying to merge, git merge, go out and merge in the changes from the feature C branch. So pull in the changes along where feature C is onto my branch. And I'm going to hit enter on this. What's going to happen? Well, it's going to say create a merge commit. Now, how does this work? I'm just going to call this merge branch feature C. I'm not going to tell it why this merge was necessary, but if we're doing something more complicated, it will make more sense to kind of specify why you're doing this. But we've created a new commit. That's going to be this commit number 7 here. And then I'm going to right quit enter. So the way I did that, just Vim is a little weird. Colon W Q enter to right quit, and you can see merge made by the ORT strategy. So ORT is a algorithm that Git uses to merge things, and you can see that it's gone out and found the changes to file 3, which we didn't previously have on this branch before, and it has merged them in. So what does my git log look like now? Well, you can see we've actually branched off, added new feature, added info D, and then, yeah, we've merged things in. And what has happened? We've actually created this brand new commit that that takes in the changes from feature C, which are those adjustments to file 3. And then we've created another new commit that branches in. So you can see we used to have these commit hashes. Now we have some new stuff. Great. So this is how this all works. And if we do git log, instead of one line, let's do stat. So yeah, what's happening? We have a whole set of commits, and yeah, we figured out how to pull the changes to file 3 into our main branch. And so practically speaking now, if we ls-r, or maybe I'll just show tree, here's our folder structure. We have everything in, and that file 3 is in the state it was on the other branch. That's what happens after the merge. So if we just look at file3.txt, then you can see we've got all the changes here. And so the whole commit history has been reconciled. Now, sometimes it is not so simple. So what happens there? We have what's called a merge conflict. So let me see if I can just create a merge conflict for you. So let's go back to this nice little one-line tree. So I'll create 2 new branches. I will first check out -b. Well, okay, let's see. Let's set up something that is going to conflict. So I will create a new file called file5.txt, and I will put some info that will conflict later. And we'll just have the number 5 here for now, right? And so if I git add dot and git commit -m file 5 created, then I have a new commit along this history, right? And so we've already done this merge, but this is going to be my basis, and we're going to create a merge conflict in file 5. So what would a merge conflict look like? Well, let's git branch. So I'm going to create a new branch, and it's going to be called change to 42, and I will check out that branch, or let's switch onto it. It doesn't really matter again, to 42. So if I check where I'm at, you can see that I'm on change to 42. And if we look at our log, you can see that we have 2 branches pointing to this commit where we've created file 5. Let's do some new stuff. So let me go into here and find file 5, and let's change this to 42. Nice. So I've written that. If I check my git status, right, there are changes in my working tree. Right, again, keeping this mental model in our heads, there are changes in the working tree that have been modified, so I need to stage them for commit. I will git add file 5, git status, and you can see I put them in my cache, which is my staging area. And if I just check the diff, right, git diff cached, then you can see it used to be this, but now it's that. So that's the change I've just made. So I will git commit this, and it's like, yeah, changed to 42. Nice. Now git status. Cool. So if I check my my history at this point, now this branch has jumped ahead. I've changed that one thing to 42. Now let's go back to where main is. So if I git switch main and I check my git status, what should be in file 5? Well, let's just see. So number 5, right? So does that making sense? I jumped back to where main was. That file is in the state it was before. So if we git log stat, let's do it with all. Just to be clear. So if I'm on main, then the change to file 5 that created just the file 5 with number 5 is where I'm looking at. I can't see that change that changed it to 42. Great. Okay. So then last thing is going to be to checkout-b is to create a new branch and switch to it. So I'm going to git checkout-b, change to, what's a good number? 37 is a good number, right? It's the difference between 5 and 42. So git status. Let's look at this. So how should our log look? Well, you can see we've created a new branch and we've switched to it. So that checkout-b is just a way to quickly type, create a new branch and switch into it. So you can see my head is pointing to change at 37. And what is the contents of file 5? Still 5. Now let's create a new set of commits. So if I open that file up for editing, then I change this to, what should I change it to? 37, I said I would, right? So let's do 29, Control A, that's needs one more. Okay, good. And I've accidentally created a file called F2 because I'm silly and typed the wrong key, so I'll just delete that. Git status. So you can see we have a modification here. Git file5.txt, right? Oh yeah, git file5. Git add file5.txt. We're going to commit it. Changed to 37. Nice. Oh, right, yeah. So you type with I, you hit escape, you hit colon, WQ, enter to exit. If you ever end up there, just remember that's what you do. Cool. So if we look at our log, where's our log? Nice. So we again have the situation where our branches are divergent, but now we have edited the same line. How on earth are we going to reconcile these changes? So let's just remember what branch we're on. So I'm going to run this merge command. I'm sitting on 37 and I want to merge the changes from 42. So how do we do that? Well, we say git merge change to 42, right? When you say merge, you're saying I'm sitting on this branch, go look for the branch I specify in the command and pull those changes onto this branch. Now when I do this, it's going to say conflict. I don't know how to do it. Why is it that there's a conflict? Well, we've changed the same line in the same file and it doesn't know which one you want to do. So if we go into file5.txt, right, you can see this is the conflict notation. So it says head, where you're sitting right now, is what this looks like. And this is what it looks like on change to 42. So which do we want it to be? Well, obviously 42. 37 is a silly number. 42 is the answer to life, the universe, and everything. So I'm just going to delete those lines, hit right, and then type this command. I'm going to type git merge continue. I have now told Git how to fix the conflict, and now it can say, I have to git add them first. So I git add dot, which is all the files in the working tree. So I made a change in my working tree. Now I can run continue. And now it'll say, why do you want to do this merge? Well, that's all I'm doing. So I've, saved my stuff, and now voila, we look at the log and boom, we have merged these things in. And now let's say we want it to update main. How would we do that? Well, we're going to run a merge on main. So I'm going to say git merge. So what will happen? If I was silly, I know I'm sitting here and I want to say git merge in the changes from main. If I do that, it'll say, well, it's already up to date. You contain in yourself all of the history up to that main contains, right? If I want it to update main, I actually have to switch on to main, right? And then I have to say git merge all of the changes up to this one here, change to 37. Now it's funny that I have changed to 37 because I changed it to 42. So that's maybe not the best example of naming your branches, but the branches don't, their names don't matter to Git. It doesn't care, but they matter semantically to us. So anyway, I'm sitting on main and I'm saying I want to fetch all the changes from this branch change to 37 and update main with all of those changes. So if I git merge main, this is going to be a fast forward merge because there is a path through the history that we have already reconciled because we've already fixed that conflict in change to 42 and change to 37. So we can actually bring things up to date. Wait, did I? Yeah, I git merged main into main. So yes, it's already up to date, obviously. That's a good example of an idempotent operator, something like that. It just gives you the identity back when you try and do something with the identity. That's nice. All right, we're gonna git merge change to 37. And we're updating this. We went from this commit hash to this commit hash, which you can see up in our tree. Looks like we are sitting here at 64DF71E, and we have gone all the way up to C321152. And it's saying updating this one to that one. So we've moved our branch pointer up, and it was a fast forward merge, and it tells you what happened in that merge. All we did was change file 5, and we, adjusted it accordingly. Nice. So if we take one final look at this one-line log, we will see that, yes, main is now up there, and sometimes we can do stuff like this. So we can git branch -d. So you can, when you use this capital D, that is like a forced delete. So be careful with it. I don't know if it'll let me delete it with change to 37. Let's see. So yeah, I've deleted that branch. And what does that mean? I just got rid of a pointer. So I'm cleaning up this stuff. So if I look at this log, you can see that there is no more mention of change to 37 anymore. It's just like, we figured it out, and yeah, we don't talk about that one anymore. That branch pointer is no longer pointing at our history of commits. So deleting branches can be scary, but yeah, that's how we do it. And yeah, I could get rid of this change to 42, I believe, too. So branch changed to 42. And now if we check our git log, it just has these commits, and there's no more pointer pointing back. So yeah, that's a nice way of thinking about it, right? It's the pointers don't really affect the commit history, and as long as we're not losing commits, Git is happy to let us delete those branches after we're done. So now, as we look for this, right, we still have all these junk branches around. So one step you might run, after a while, you have so many branch names in your namespace, we can git branch -d, we can get rid of new, we can get rid of new branch. For FF, we can get rid of feature C, and we deleted all those branches. So now we just have main, right? We're back to, what am I doing? Git branch. So if we just check git branch, you can see we just have main, and all of those former branch names, which were just pointing at the graph, remember, are gone now. And so we still have our full commit history. Remember, the branches and the commits are different things, but now it's a nice clean commit history, and we can see everything that happened as we went. So we had an initial commit, we added feature A, fixed bug B, refactored the code, added feature D, added new info, and then we merged those two things together. We added a new file called file 5, we changed it to 37, and then we changed it to 42. We reconciled those things, and we merged it all together into main. So yeah, that is what happened. And you can see there are some mentions of those branches in the commit messages themselves. So you might not want to delete some branches at some point, especially if you made like kind of a major decision that you might want to go back to in the future. But it's all recoverable, right? We can still go back to here, and if we were to if we were to go back to here, right, and we check this out, then it's like we are now back there, and the state of the project at that point, right, if we ls everything, there's no file 5 yet. And so all of the states of the project across all of the different branches are accessible again. And we have a nice way of tracking how all the different branches broke out and how they came back together. So yeah, that is branching and merging. Sorry, this was a little bit involved and a lot of words kind of quickly, but I hope there were some practical examples in here that kind of helped you get a sense of how this works, as well as some diagrams and pictures that kind of helped you make sense of what was going on with all this branching and merging. This set of concepts takes a long time to kind of feel in your bones. I think only just when I was making the tutorial did I like really understand it, and that's just a common thing you'll encounter in life. I think they call it the Feynman technique, right? Richard Feynman would always say that when he was learning something new, the best way to learn it is to have to teach it to somebody, because you really can't BS it. You have to know what's happening, right? So it's going to take some time to get this into your bones, but I hope that you can sort of see the appeal of running a project like this, and why we end up with these two mental models to think about it is because these are the two things you kind of need to know to work with Git effectively, and you get a lot of benefits from doing that. So thank you very much, and I will see you in the next one.